All right, the next section in your textbook, which is Chapter 20, Section B, talks about finding the derivative for specific x values, and we're going to skip over that because I don't like the way that it's taught, and besides, if you know how to find the derivative for all values of x, which is what Section A was, if you know how to do that, then you can just plug in whatever value of x that you want. So we're going to skip over that part. We will do questions like that in class, but I'll show you how to do it. It's just one more step than you've done before. So we're going to go ahead and move on to Section C, which is simple derivative rules. From now until the end of this chapter, we're just going to be accumulating rules based on what you get for the derivatives of functions. And all you need to do is remember those rules, because you really don't want to plug in a function into that whole limit of f of x plus h minus f of x all over h. You don't want to do that every time. So if you can remember what you got, then you can just apply those rules to any given question. So one of the questions that you did in your last exercise, it asked you to find the derivative or find the slope of f of x equals x. And hopefully you got that f prime of x, that's how I'm going to say this, f prime of x, which is the derivative of x, that's equal to 1 everywhere. All right? And then the example that I did in the last video, one of the examples I did was f of x equals x squared, and the derivative of that, which I'm calling f prime of x, is 2x. So it's always double the x coordinate to figure out how steep the slope is at that point. Then there was another question that you had to do where the function was x cubed, and hopefully you figured out that f prime, or the derivative of f of x, is 3x squared. And there was a question where you had to find the derivative of x to the fourth, and if you did that, the derivative was 4x to the third. And I don't know if this question was asked, so maybe I'm just giving this one to you, but if you were to do that same situation with f of x equals x to the fifth, then you would get f prime of x, or the derivative of f of x, equals 5x to the fourth. So after doing the first 5 of these, I'm hoping that you notice a pattern. Okay, so if you don't notice the pattern yet, just press pause on your video, and then once you get it, press play again, and we'll move on. Okay, we'll move on. So hopefully you've noticed that the old exponent of your function f of x became a coefficient out in front, and the new exponent of x, the exponent of x for the derivative is always 1 less than the exponent of x that you started with. So how do I write that? I say that if f of x equals n, or x to some exponent n, then f prime of x is going to be n times x to the n minus 1. Okay? And that applies anytime you have x to the n, some variable to a number exponent. All right. So, just as an example, if I had f of x equals x to the 37, then what would f prime of x be? Well, I would move the 37 out in front, and I would reduce it by 1 to get my new exponent. So that would be 37x to the 36. Okay. Moving on to some trickier things. If I had f of x equals 1 over x, then what is f prime of x? Well, this is not written as x to some exponent, but it can be if I were creative about it. So since 1 over x can be written as x to the negative 1, that's how I'll write it, and then I can follow this rule. Okay? So that means that the negative 1 comes out in front, and I reduce the exponent by 1 to get my new exponent. So f prime of x equals negative 1 times x to the negative 2. Or you can write that as negative 1 over x squared. Okay? And that's my derivative. What if I had something like this? If f of x is the cube root of x, then what is f prime of x? And again, I've got a situation where it's not written as x to some exponent n. So I need to change it so that it does. All right, so I'm going to write it as x to the 1/3, and now I can follow the rule. The 1/3 goes out in front as a multiplier, and then I reduce this by 1 to get my new exponent. So 1/3 is my coefficient out front, and my new exponent is negative 2/3. That's what I get when I do 1/3 minus 1. So the derivative is 1/3 times x to the negative 2/3. All right, and that rule only applies if you've got x, a variable, to the n, some number n. Okay? Don't think that you can apply it to something that's close to that, but not exactly like that. All right, you can only use that rule for these types of functions. All right, here's another simple rule. Okay, if I've got some function f of x and I decide I want to multiply it by a constant, then the derivative is also going to be multiplied by the same constant. That makes sense. If I multiply f of x by a constant, then what that's doing is it's creating a vertical stretch. So all of the slopes that were on the original function are now steeper than they were before by that vertical stretch. Okay, so for example, if I had f of x equals 17 times x squared, then what is the derivative of f of x? Well, I know that the derivative of x squared is 2x. So if I multiply that by 17, I'm going to multiply the derivative by 17 as well. Okay. Oops. So that means that the derivative of 17x squared is equal to 17 times the 2x, which is the derivative of x squared, and that works out to be 34x. Okay. And if f of x equals 5x to the 9, then what is f prime of x? Same situation. I know what the derivative of x to the 9 is. That's 9x to the 8. So if I multiply that by 5, because the function is being multiplied by 5, I get 45x to the 8. Okay, so that's another simple rule. And yet another one. If I have two functions that are being added together or subtracted, then the derivative is just the sum or difference of those derivatives. So let's look at an example of that. If I've got f of x, which is x cubed plus x to the 7, then the derivative of that is going to be whatever the derivative of x to the third is plus whatever the derivative of x to the 7 is. All right, I know the derivative of x cubed is 3x squared, and I know the derivative of x to the 7 is 7x to the 6. So I add those together and I get the new derivative. It's 3x squared plus 7x to the 6. All right. Let's combine those two rules on this next example. If I have f of x, which is 2x to the 6 plus 2x to the 5th plus 4x to the 6th, then what is f prime of x? Well, I know that the derivative of x to the 5th is 5x to the 4th. So this is going to be, the derivative of this is going to be 2 times 5x to the 4th. And the derivative of this is going to be 4 times 6x to the 5th. So that gets me 10x to the 4th plus 24x to the 5th. Those are the only simple rules that you need to know. And this is just me writing them in notation. So the first one is the same as you saw it the first time. If a function is x to some exponent, then you bring that exponent out front as a multiplier, and to get your new exponent, you decrease the old exponent by 1. If your function is some other function multiplied by a constant, then you will multiply the derivative by the same constant to get the new derivative. And if a function is two other functions that are being added together, then the derivative of that function is just the sum of the individual derivatives. Those are the only simple rules, so please don't try and create other rules. For example, there are no simple rules for multiplication and division. There are rules, but they are not as simple as the ones that we just discussed. All right? So if f of x is equal to two functions, g of x and h of x multiplied together, then the derivative of f of x is not the same as the derivative of g of x times the derivative of h of x. That's just not true. And let me show you with an example. If I were to say that my f of x was x to the 7, I know that that's the same thing as x to the 3rd times x to the 4th. So what I'm going to do is I'm going to find the derivatives of these separately and hope that they're going to equal the same thing, but I just told you that they're not going to be the same thing. So I know that if I focus my attention over here, the derivative of x to the third is 3x squared, and the derivative of x to the fourth is 4x to the third. So if I multiply those together, I get 12x to the fifth. But that's not what the derivative of x to the seventh is. The derivative of x to the seventh is 7x to the sixth. Okay? And sure, maybe 12x to the fifth is sometimes equal to 7x to the sixth, but that's not enough. It has to always be equal. Okay? So I needed to get the exact same answer for both derivatives in order for that rule to be true. And I didn't get the same answer, so that is wrong. Okay? There are rules for multiplication and division. The one for multiplication is called the product rule, and the one for division is called the quotient rule. And we will talk about those, but those are a little more complicated. They do always work, but they're not as simple as what I've got up here, the thing that doesn't work. So we'll talk about those later, but for right now we will do just the simple rules for differentiation.